Okay. Hi to Dr. Majid. We are from Group 4. The members consist of Jia Yufeng, me Aisha, Lia Tian, Siti Nur Aninoha, Aisha Huwaina, Limi Chiu, and also Tam Chi Cheng. And we will present on Finitely and Infinitely Repeated Game. For the introduction, before we move to the dynamic games of complete information, we will just define the meaning of dynamic, complete, and also information. The dynamic games are where the players move sequentially or repeatedly. It is useful to analyze the dynamic games in the extensive form, where the extensive form games are the sequence of moves, and the actions of each player can make other players to move. It is important to understand that the action an action is the move of a player by a given point, and the strategy species of the player we take for every contingency. Okay. Next, for complete means that the players pair off from each feasible combination of moves or common knowledge, means that the players knows each other's strategies. Also, information can be either perfect or imperfect. For perfect information, is all previous moves observed before the next is chosen. This can be seen on the chess games. Next, imperfect information is the move may not be observed before the next is chosen. And this means that the players knows each other's strategies but do not have any idea which one they had been used. Okay, next for the dynamic games of complete information. Dynamic games of complete information are games that play sequentially. They are usually depicted by extensive form, specify the players, and then when each player gets to move. For example, for the two players, player 1 and player 2, usually player 2 will make a move based on the player 1 action. And the third one is players' available choices and information, and lastly, payoff after sequence of moves end.
Hi, my name is Siti Nur Mohammed Gani. Okay, now I will explain why we are using subperfect equilibrium but not Nash equilibrium in dynamic complete information game. First, we need to understand that in complete information static game, we find the Nash equilibrium because the game is only played once. While for the complete information dynamic game, the game is played more than once, whereas players take turns after observing other player action. This leads a different interested solution. This means that we find the Nash equilibrium for the former and subperfect equilibrium for the latter one. This is because in sequential game there is a concept called the Kiribati trick, which means the trick which is the rationale to be carried out and forcing you to take the strategy. So what is the relationship between the Nash equilibrium and the subperfect Nash equilibrium? A Nash equilibrium is said to be a subgame perfect if only if it is the Nash equilibrium in all the subgames. This also implies that all the subperfect equilibrium will be the Nash equilibrium, but the converse is not true. This credible trait can be easily checked when we compare the game in normal form with their extensive form.
I will now start with backward induction. Backward induction in game theory is an iterative process reasoning backward in time from the end of a problem or situation to solve finite extensive form and sequential games and infer a sequence of optimal actions. It proceeds by examining the last point at which a decision is to be made and then identifying what action would be most optimal at the moment. Using this information, we can then determine what to do at the second to last time of the decision. This process continues backward until the best action for every possible situation at every point in time is determined. Basically, backward induction works because backward induction enables players to acknowledge the current strategy is better or not than in the future. This means that we must know what is going to be happen in the future, then compare with current strategy. If we are aware of the future payoff is better, we proceed. Otherwise, we will stop so that the future payoff will not happen.
Hi, I'm Chi Cheng. I'm now going to explain about the finitely repeated game. So, recall for the prisoner's dilemma game. In one shot game, both players are going to defect and get a payoff which is worse than the payoff for the cooperation. So, here comes to a question. If the game is repeated finitely, so is it possible for the players to cooperate and gain a better payoff for the both players? So let's say the game is repeated 3 times. What is the sub-perfect Nash equilibrium? To find the sub-perfect Nash equilibrium, we can apply the backward induction. Why? This is because the game now is complete information dynamic game. To see how it works, let's have an example to solve this.
Hi doctor, I'm Lia Tian. So now I'm going to present the example of finally repeated games. Let's solve the game using the example. Suppose the game is repeated 3 times, stage 1, 2, and 3. In stage 3, this is the last stage that the players play the game. So in order to gain the maximum payoff, both players will just play the Nash equilibrium strategy. In this case, mutual defections occurs as in one shot game. Next, we can update the strategy as well in stage 1 and stage 2. In the stage 3, we can see is defect defect. In the stage 2, both players knows that the last stage their opponents will defect on them. Given this, the best strategy for the player is to defect on you as well. This yields that the same result, which is the mutual defections occurs. So the same logic applies with stage 1. Next, as you see, stage 1, 2, and 3 is both defect and defect. As such, the sub-perfect equilibrium is to play defect in all the stages. This gives us conclusion that for a finally repeated game, if there exists a unique Nash equilibrium in the one-shot game, then the Nash equilibrium is also the unique sub-perfect Nash equilibrium.
Hi, I am Aisha Huaina. So today I will explain infinitely repeated game. What if infinitely repeated? So consider the same game but now repeated infinitely. Previously, we have found that cooperation cannot happen in a finitely repeated game. What if the game is repeated infinitely? Two questions arise. First, if no one defect, will anyone want to? And another question is, if the defection has been triggered, is it the SPE forever? The latter question has been shown in the finitely repeated game. So we have to show the first question after explaining the discounting factor. In this game, when cooperate, both players will get 3 as a payoff. But is it today $3 good as tomorrow $3? Obviously no, because you can ensure the game will continue. This is where discounting factor will come into place. And this discounting factor can be taught as a passion of player.
Hi doctor, I will explain the example for the infinitely repeated game. So, using the same example, in this game we have the strategy known as the green trigger strategy. And the strategy is as such: play cooperate forever if others also cooperate. Play defect forever once the other deviates, means they defect on us and then we defect on them. So suppose that both players are adopting the trigger strategy as above here, and since the game is symmetry, it is sufficient for us to consider the payoff on one of the players only. So suppose that we are player 1 now. So our payoff if we cooperate is actually 3 plus 3 times with the discounting factor and discounted appropriately. And this has been explained in the previous conceptual there. The $3 today is better than the $3 tomorrow. And so the second day we will multiply the value of 3 with the discounting factor. And if we defect on the first day, so we will get 5. This can be referred from the payoff matrix. And then since we defect on the first day, our other player will defect on us forever as has been mentioned here. So we will get the payoff of 2. and discount appropriately. So in order for us to cooperate, the following inequality must hold. That means the payoff for cooperate must be greater than or equal to the default payoff. And solving this inequality, we will find that the delta is at least 2/3. This means that the cooperation is actually possible if the player is patient enough, which means that the delta is at least 2/3. That's all from me. Thank you.